Hey guys, Mr. Gibson here. So I just wanted to record a quick video to get you guys started on Explore 3, which is the environmental effect or environmental impact on gene expression. And so we've talked about gene expression a little bit and how genes get turned on and off and how the different combinations will give you different functions in that cell. Now let's talk about maybe some outside factors, some factors in our environment that might result in some of our genes getting turned on that were previously turned off, or some genes getting turned off that were previously turned on, and therefore affecting our traits, because those genes would then affect our proteins, which affects our cell functions, which affects our physical traits. So let's take a look at this assignment. So does your environment have an effect on genes, on which genes are expressed and which are turned off? I want you to think about that for a second. Maybe pause the video for 5 or 10 seconds and just think about that question. Think about what your opinion is right now, and that's okay if it changes throughout this activity, but think about, does the environment that you live in affect your traits? Does it affect your genes? All right, now open the Google Doc and read the information, then open the Google form, and using the information in the Google Doc, you're going to actually make a CER today. You're going to answer a CER, basically answering this question, but within a real life scenario. So let's take a look at, so it's going to give us an example using rabbits, and then it's going to have you write a CER using a real life example. So here we go. It says, you now know that all the DNA in every cell of your body is the same, which when genes are turned on or off, they determine the types of cells that will form and the types of traits that will be expressed. And so so this is going ahead and telling you, yes, environmental factors can play a role in gene expression. So here is the example. So here we have two different pictures. We've got the snowshoe hare that when it is warm out and when there's no snow on the ground, it has a brownish gray color to its fur. And when it is snowy, so during the winter, it has white fur. Now these are the same organism, same individual here, okay? What's different here is when it is warm out, when the ground is not covered in snow, it's covered in grass and underbrush and leaves and sticks and things like that, it is more advantageous, meaning it's better for survival for the snowshoe hare to not have white fur, because then it would stand out in front of all the grass and trees and whatnot. So they've evolved so that during the spring, summer, and fall months, their gene to produce a pigment, which is what gives things colors, is turned on. So this gene in its cells gets turned on to make this protein pigment, which gives its fur a brownish gray color so that it blends in with its environment. Now, when the winter months hit and it starts snowing, obviously it would not be great for that rabbit's survival if it's running around on a snowy plain with dark brown fur. It's going to stand out to predators. And so during the winter months, that gene actually gets turned off so that it stops making that protein pigment to give the fur a brown color. And so at that point, there is no color in the fur because that pigment's not getting made, and it has a white color to its hair or fur. And so that is advantageous for it during the winter, because then it'll blend into the snow. So knowing now that environmental factors do affect gene expression, which genes are turned on and off, and seeing an example of it with the snowshoe hare, here is your assignment. Here's your CER. So here we have identical twins. Here's the scenario. We've got identical twins born, and twins are pretty much, if you're identical twins, you're pretty much clones of each other. You've got pretty much the same DNA. However, as they age, environmental factors can influence which genes are expressed in each twin. For instance, if one twin is a smoker, that twin will show differences in his or her aging and wrinkling of skin, because the carcinogens that they're taking into their body will affect how often that their cells are having to divide, and so that will affect to repair damaged tissue from the smoking, and so that will affect which genes are turned on and off as far as like aging and wrinkling of skin. So imagine if a set of twins were born and adopted, but by two separate sets of parents. Okay, so they move far apart from each other, even though they're twins. And below is a list of different lifestyle factors in their lives. So for example, twin one was raised in Colorado. They ate a high protein, low fat diet. They were very active physically. They wore sunscreen when they're outside, and their parents were non-smokers. However, twin two, even though they have the same set of DNA, here's their environmental factors. They were raised in Florida, so think there's going to be a lot of sunshine there. They ate a high fat diet. They only exercised periodically. They weren't really active. They went to the beach and pool all the time in that high intensity sun in Florida, but did not wear sunscreen. And their adopted parents were smokers, so they're getting that secondhand smoke inhalation. So what you guys have to do is use a scientific explanation to explain in your own words how their genes would be affected. And your claim is going to be this. You're going to answer this question. Do you believe the twins would still look 100% identical, indistinguishable, when they reach the age of 35 after being exposed to these environmental factors for 35 years? Okay, so let's go to your CER, and I'm just going to show you what it looks like. Move this. Okay, so here you get, the general information I want you to give. And then I've got that same scenario with the twins here typed for you, so you don't have to click back and forth. And then you're going to answer the claim. So your claim, you're just going to simply answer this question. Do you think they would still be identical at the age of 35? Your evidence, you can pull from here for your evidence. You can also pull from stuff up here about environmental factors, infected gene expression, and all that stuff. And then your reasoning, remember, you just want to have a solid paragraph explaining how each piece of your evidence supports your claim or proves your answer correct, okay? Think about you're arguing it. Maybe you're arguing against somebody here who has an opposite claim and you're trying to prove that you're right. Think of it that way, okay? So this is all you have to do today is read that information, do the CER, and turn it in. If you need any help, feel free to email me or call me. Good luck, guys.